Great, thank you very much. My name is Frank Yu. As you can see on the slide, I'm a solution architect for Kemp Technologies. And I have with me Kurt Young, and he's our technical marketing engineer. And we're going to be discussing, as you can see, the Kemp Dell EMC ECS solution and how we bring the things together and why we bring things together. And if you don't know what ECS is Elastic Cloud Storage. So it's their object storage solution for changing the way we do the storage of the databases and the files and the objects, and we'll discuss this as we go through the presentation. But first, what I want to do is give you a quick overview of who Kemp is, why we're here, why we think we are relevant, at least from my perspective. Everybody else's perspective will be a little different, but that's fine. And Kemp, we've been in business for about 15 years or so. We started in the early 2000s. We have about 200 employees. We're a global company. As you can see, we have offices. Our corporate headquarters is in New York City. We have a large operations and development office in Limerick, Ireland. And we also have offices in Munich, Hanover, as well as in Singapore, covering the Asia-Pac region. So we are a global company. We have a lot of customers. You can see over 25,000, 60,000 deployments deployed in over 100 countries, which is about, a little more than half of the countries on the planet, which is not bad, I like to say. And we've been in this load balancing business, and it says here ADC. ADC, if you don't know, stands for Application Delivery Controller. That was a term coined about 10 plus years ago. And Application Delivery Controller, I always like to set the stage for everybody. Application Delivery Controller is a fancy load balancer with fancy features that does more than load balancing. But really and truly, we're all load balancing. But we might do other things like web application firewall, security, two-factor authentication, security protections, things like that included within the load balancing technology. But primarily, we're talking about load balancing. And when we talk about load balancing, it's all about application delivery. When we talk about load balancing, the first piece is we sit in front of the applications and we provide availability, security, scalability, redundancy, et cetera. And these are the key reasons why you want a load balancer in general. Number one, you want that availability. We sit in front of the servers because we protect the environment from disruption. So if a server fails in a pool of servers, we automatically detect and we don't send client traffic to that server. When it comes back online, then we start sending traffic to that server again because we're doing the checking of the application and the server to make sure things are good. This is something very critical and core in terms of load balancing capabilities. And it's something that because we sit in front of the application servers and we front the application, there are a lot of other cool things that we can do for that client application traffic. For example, now we can do the scalability. So when you need to add more servers to your pool, you don't have to have any disruption to the clients and add things or change DNS. All you do is add it to the pool of servers behind the load balancer, and it automatically detects and starts directing traffic accordingly. If you have maintenance windows, take servers offline, do upgrades, things like that, again, we automatically do detection. There's nothing necessary for you to do. Security. We provide the security for the applications. So like I said, we can do web application firewall. We can do a lot of basic network-based protection like SYN flood protection for DDoS attacks. We can do things though for content inspection to make sure things are appropriate. So again, web application firewall, we can do things like support OWASP top 10, PCI DSS compliance issues, HIPAA, and things like that for your applications. Performance, because we sit in front of the applications and sit in front of that pool of servers again, we can do things like do SSL offloads. So we terminate all the SSL connections. So we handle the encryption and the certificates and manage all that so you don't have to deal with it all on the individual servers. And we design the platform for the load balancer to really encourage it to be a high performance engine to do that at high performance rate so we can support hundreds of servers potentially within single load balancer infrastructure. And control. Because we're in that point, we see all that traffic coming to and from. You might have load balancers for all your dozens or hundreds of applications that you have in your network and your environment. What we can do is we can give you centralized control to manage those applications. So all the load balancers are managed from one central point. You can deal with configuration, change management, policy, distribution. So it makes it very easy for you to manage your application infrastructure from a single point for the load balancing technology. And at Kemp, this is how we break out our product portfolio in terms of the solutions that we provide. Number one, you need the load balancing technology itself. So our load balancer, our brand name for the load balancer is LoadMaster. It does the load balancing, it does the optimization of the traffic, does the security like I talked about, gives you that scalability, all the core functions of the load balancer. And in terms of form factor, we can give you the form factor in terms of hardware because people still use appliances. But really the world is moving to a software world, and we tend to be focused on the software world, where if you want virtual versions, so you can sit on any sort of hypervisor and any sort of orchestration engine, like you can support KVM, VMware, OpenStack, Hyper-V, whatever the situation may be, the virtual versions can sit on. And we also support cloud environments. So public cloud like AWS and Azure. You can buy it through their marketplace, or you can do what we call BYOL, bring your own license, where you can pin up your own VM in the public cloud and then apply the license to it and get the functionality.
The appliance, does the appliance have a specific hardware for the acceleration?
That's correct.
Okay, so it's faster than the other version?
Yes, sir. So for the appliance, for the hardware platform, that we're, again, like I said, since we're primarily a software company, what we've done is we've taken basically our spec of a COTS, common off-the-shelf hardware framework, to design our hardware platform. So a standard, there's no proprietary technology. We don't have specialized FPGAs or ASICs. The standard off-the-shelf hardware that we've certified that we believe is best fit for the solution for the hardware. So we use Intel CPUs as PCI-based buses, and for the acceleration, then it's all PCI-based using something like a Cavium Nitrox for your SSL acceleration hardware, and you can drop that in just like you would in a server. And we can provide the additional performance for that. Make sense?
Totally.
And then, talking about the visibility and control, we have the other product called 360 Central. This is our centralized management platform. So if you have one or two load balancers, you may not need that. But as any reasonable sized company starts to grow and scale and add more and more load balancers in multiple pairs and multiple sites, you don't want to have to manage each device individually, right? And that's true with all technology. So we have our centralized management with 360 Central. It's an automated platform that really gives you that central point of control for doing config management, code version management. In terms of analytics, we can give you analytics on the performance of the different load balancers in the different environments. And we can even do configuration and capabilities. Yes, sir.
So presumably this would go hand in hand with, say, a globally distributed deployment of ECS, where we have load balancers deployed everywhere. We want to keep things consistent. We leverage 360 Central.
That's exactly right. You're taking, you can come up here and do the story just like that. And what I would say is that's exactly what you want to do. If you have global deployment or remote deployments or things like that where you don't have to or want to have engineers go and connect to all the end user devices, number one. And two, you want consistency. Like for a global ECS deployment, you have multiple load balancers in the multiple sites, but they're all going to be configured very similarly in terms of capability, because they're all working for object storage. So you want to have some sort of configuration template, and we can make sure that you have a template that fits that model in terms of policy management for configuration. And the third piece here is what we call 360 vision. It's kind of tying on and extending what we do with Central in terms of the centralized management and analytics. But now we want to start becoming predictive. Predictive from I'm going to say from an AI, ML, machine learning heuristics perspective. And those are buzzwords, and maybe we're overstating and understating. But what we're doing is we're collecting data on the performance and stats on how your load balancers and applications are performing, and can give you now automated feedback in terms of performance issues or concerns. This application is underperforming. We have an outage here. We have things going on there. We'll give you an alert and say, this is what we're seeing. You might want to take some action, and here's even a possible recommended action that you want to take based on our intelligence, our experience in the industry, and the way the things work, and then incorporate that into this 360 vision. And we actually have the 360 vision to the point where we actually can have our support team with the humans on 24/7 also provide some feedback as well. So it's the machine learning as well as potentially human interaction to provide that feedback for truly as a service. Because that's one thing that's tough about load balancers. Let's take a step back. Load balancing technology is not networking. When I think of networking, I think of routers and switches, spanning tree, VLANs, routing protocols, OSPF, BGP. And I used to do that many years back. And then you have server guys that deal with, I'm going to build these servers, I'm going to put this OS on, I need CPU, I need memory, I need to, or the developers that are writing the apps in whatever programming language they want to write it in, whether it's Python, Node.js, or whatever it is may be. And load balancing kind of sits in between. It's not networking per se, in that traditional networking. It's not application server per se, but it's somehow in between. Because we deal with application, but from the network perspective. I like to say we're application networking technology. So it's a very niche space, so it's very hard to find people that know the networking and the application to really understand load balancing technology. And that's why I think it's critical for us and the industry to provide this extra expertise and insight for the organizations that need that help to get that expertise.
So this is actually on like layer 5, 6, 7 kind of network concepts?
So load balancing works all the way. So load balancing traditionally we used to say is layer 4, 7. Mm-hmm. Layer 4, TCP, UDP stack, all the way up to content manipulation and things like that, right? Mm-hmm. But really and truly, load balancing is layer 2 through layer 7. It's everything except the physical.
Right.
So that's the challenge, is that somebody needs to be an expert at every single layer. And I know the OSI model doesn't map everything.
I know.
Right? Like HTTP. Is that layer 5? Is that layer 4? Is that layer 7? I'm not sure. I think HTTP is a transport, in my opinion. So it's kind of layer 4 or layer 4.5. SSL, that's not layer 4, it's not layer 5, it's 4.5. Right? So it doesn't quite fit, but we have to know something about everything. So we're kind of a jack of all trades on the entire OSI stack, while other IT professionals from architecture operation tend to pigeonhole or contain themselves in certain aspects of it.
Okay, sure.
So let's move to the next step. We've talked about Kemp and we've talked about load balancing, and let's talk about object storage. Object storage, what is it? What are we doing and why are we doing it? We've had storage systems in the past and they've kind of worked. Back in the old days, I used to deal with NFS. And as a networking guy, what a pain in the rear. I wasn't the storage guy or the data guy, so I didn't understand. My wife is, so she doesn't understand me. But object storage moves to another level of what we're trying to do with these files and data. So let's take a little primer and just make sure we're all baselined. Understand what we're talking about and why we're doing object storage. Why does ECS exist? Why are all these organizations moving to this object storage models?
Because they are saving a lot of cat pictures.
What's that?
No.
We won't discuss what content they are. We'll discuss the type of content. How's that? So what is the problem? Number one, there's more data. I mean, we've been talking about big data for quite a few years now, and this big data analytics and all this stuff. Global data by 2025, 163 zettabytes. I can't comprehend what a zettabyte is in my head. I can kind of comprehend what a petabyte is. I can understand what a megabyte is because I'm old school and I've got my gray hair. And kilobyte, but 1 zettabyte is 1 million petabytes. So it's these orders and orders of magnitude more data, which is astounding how much data we're collecting, and we're not throwing it away. We never throw our data away. We just collect, accumulate. We're hoarders with data. In 2016, there was a 10-fold increase in terms of the amount of data coming in. Why is all this data coming in? Well, one issue is we have this concept of Internet of Things. We have all these devices that we're deploying the network that are not human-driven, that are sending data, whether it's CCTV, Whether it's these devices for industrial IoT for like your electric bill or your water utility meter or all these other devices, we have tons of devices that are sending data to points that we are collecting and storing and doing analytics and information on. So it's just compounding at a multiple level how much data we're collecting that versus what we did in the past. And again, going back to big data, we're collecting all this data because we want to do all this cool analytics, like IBM Watson, where we're doing all, in theory, how true is big data and how good are our analytics? It's early on. It's certainly not Skynet. Not yet, I'll say. By the way, Skynet's going to come eventually. But I always say it's going to be the human-friendly version of Skynet, if I can say that. It's not going to try to wipe us out, at least I hope, knock on wood. But we are doing all this analytics because we have all this data, because let's go back. I'm not a baseball fan, and I apologize if you are a baseball fan. But there's a person there, they're a baseball fan. I apologize for what I'm going to say. But baseball fans love collecting statistics and metrics on the most random parameters. Okay, this guy, when it's cloudy on a Sunday versus a left-hand pitcher in this type of field, whether it's domed or not domed, has this type of average. Wow. That's what we're doing with big data. We're just interpreting this data so many different ways. And then we have to future-proof ourselves. We have to future-proof ourselves for these modern applications, next generation things that we don't even know about. So we need a flexible framework that can adjust to these next generation things that we're going to be doing for collecting the data and doing things with this data. What is object storage not? What is different from what we used to use, like network attached storage, NAS? It was a file storage system. And it was based on a file folder type hierarchy, similar to what you have with the Unix, Linux, current OS type environment, where you have a hierarchy, you have folders, and you have files in the folders. And then you set your user privileges, again, similar to a typical OS, and you apply those privileges to the folders and files. It's good for hundreds, thousands, maybe tens of thousands of files, maybe even more, but it doesn't scale to the point of what we were talking about in terms of the big data and everything else that we're want to do. It's not flexible. And then we have storage area networks, SAN. And we have these clusters of systems that provide some sort of storage, and we split the files into blocks of data so we can stripe them, provide redundancy, and things like that. But the problem is, it's still a file with a file name, and that's it. And then we apply the privileges and everything else. There's no metadata. It's a video file. It has a name on it, but what's in the video file? Who's in it? What's it doing? What's it related to? That information is not there. And it's expensive. If you ever had to purchase a SAN or deploy SAN, and it doesn't scale. How do you scale from your cluster that you have today to something that's tenfold in size, quickly and easily? It's not something easy to do. So the traditional file storage systems that we had in the past did not meet the requirements that we want today. That's why we have gone to object storage. So now we have this elastic object storage concept. We have this storage concept where with elastic cloud storage, it's no longer files and file names and things. We have objects. The objects have meta tags. In the social media world, it would be like a hashtag, right? So here's a video, and it's going to hashtag Frank Yu on it, me, because I'm in the video. It's going to hashtag, this is industrial training video. It's going to hashtag whatever else. So there are flags associated with these files. That with this metadata, the storage and management of the data is now managed not by the storage system, is managed by the storage application that accesses this data. And we'll talk about that in a minute. There's no real file system needed, a hierarchy, because it's all done based on these hashtags, metadata, and be able to pull the objects out. So we don't need this hierarchical file storage system. It easily scales because it's this flexible dynamic environment. We can just add more disk space or memory space or whatever we're using technology-wise, quantum computing, memory space, or whatever it is in the future, and we can just add more storage and we now scale. This makes it cheaper in terms of total cost of operations and acquisition. And because we are using these applications, we now are accessing these objects and this information by an API instead of this user permission file management system. We have a lot of use cases that we use for this, for example, where we have people wanting to use this for archiving broadcast video. And they'll have their traditional storage system for the real time and the things they use regularly, but then they're going to push to archive all the videos when they get deprecated into this object storage system, because now it's flexible for archiving purposes, and it gives them the scalability and flexibility as they continue to accumulate more information. Again, with the SSL offload, the APIs and the applications can be encrypted, so we get some data protection, and we have now data protection on the network that we may not have had in a SAN type environment. So there are many ways we can take advantage of these object storage solutions.
Yeah, and just to add to that, right, the whole idea of the kind of tiered storage, right? We have a lot of customers that are going with something like data domain in front of ECS, and then, obviously a bit more expensive with data domain, but then being able to archive to the less expensive and get that low TCO. So we're seeing a lot of customers that are doing that, and a lot of customers we had conversations with this week that are looking at that kind of solution.
Great. So the applications and APIs that we typically see with with object storage, S3 is probably the most popular. S3 communications, and these are the TCP port protocols that are used for the outside and inside communications. So the first one is usually unencrypted. The second number is usually the encrypted protocol number. Atmos, Swift, and of course we can even do things like support traditional protocols like NFS with our object storage solutions. Okay? So we're all comfortable and good, and we are now the subject matter experts for object storage.